In this video from the series The Blocks in Blockchain, we'll take a closer look at blockchain limitations. This is part 2, network performance. However, maybe the better questions to ask are, what are the problems the blockchains are solving, and what are the problems the blockchains are not solving? Blockchains solve for the transfer of unique copies of digital assets or data in a network, where everyone in the network can share the same records consistently without the need for a central intermediary. Participants will share and receive updates to their records in the network. The updates to the shared data are known as state changes. Everyone can reach consistency across the network as the state changes are organized and ordered. This can be achieved by a competition such as the mining in Bitcoin, or consensus via voting to validate all the entries in the ledger. This allows the network to create an encryption signed and validated hash-linked immutable record. Blockchains also solve for confidentiality. Well, somewhat. Some may just be masking the users. Some solutions are only pseudo-anonymous, like Bitcoin, where once somebody knows your public key, they can tell everybody else who you are. Some solutions use techniques such as zero-knowledge proofs to hide identity and secure the network. However, these techniques do take a long time to calculate. So, in summary, blockchains solve for distributing consistent, unique digital asset state changes across a network, confidentially in certain cases. But aren't they ledgers too? Well, let's see. So that's the first question. But what about the second one? What do blockchains not solve for? In this video, we'll show that current blockchain designs do not solve for network performance. For this, we shall focus on or consider scalability, capacity throughput, and latency. Looking at a transaction flow with current blockchain designs, two parties need to initiate and agree their transaction. Then the network needs to organize, vote, and reach consensus or compete in mining to update the ledger. Every active node now needs to validate that activity and update their copy of the ledger. The problem is these actions are multi-step, multi-person processes, and so are low capacity and high latency. So, current blockchain designs with consensus or mining do not solve for speed, i.e. latency, or capacity. Beyond that, mining has a finite capacity, so if that capacity is exceeded in the network, a backlog will develop. With consensus, the computational demands expand exponentially. Looking at an example, 5 nodes creating 1,000 transactions each will cast 5,000 votes each. So each node has to validate 25,000 computations. With the inverse of 5,000 nodes creating 1 transaction each, they will also each have to cast 5,000 votes. But now each node has to validate and count 25 million computations. There's the exponential increase. So, current blockchain designs with consensus or mining do not solve for computational scalability. So not solving for scalability, speed, or capacity is not solving for network performance. So if you're interested in a viable DLT solution or want to contact us, go to l4score.com. We're also available for advisory or due diligence consulting for DLT for the financial services and other industries. Thank you.